In this video, we'll look at applications of quadratic functions with maximum values. Our question is, a ball is thrown into the air on planet 42 and its height in feet after t seconds is given by the height or position function h of t equals negative 21t squared plus 84t plus 100. There's a footnote. The gravitational constant on Earth is 32 feet per second squared. So in this model, Earth would be planet 32. Our question is to analyze the height function and find each of the following. The initial height of the ball is at a maximum height when t is what number? The maximum height of the ball is what? The ball hits the ground when t is what? And to provide a label graph that shows each answer. For part 1, the initial height. Since h of t is the height function, the initial height occurs when t equals 0 seconds. H of 0 is 100. The initial launch height is 100 feet. Notice the importance of units here. T is in seconds and height is in feet. The second part is the ball is at its maximum height when? Since h of t is a concave down parabola because the leading coefficient, negative 21, is negative, the maximum height will be the turning point of h of t. We must convert h of t to turning point form. We factor out our negative 21 and we have b on the inside as negative 4. So b over 2 squared will be 4. We add 4 on the inside. When we add 4 on the inside here, we're really adding 4 times negative 21. So we're really subtracting negative 84. So we add 84 here to keep that consistent, and we have our turning point form. Negative 21 times quantity t minus 2 squared plus 184. The turning point is 2, 184. So the ball is at its maximum height when t equals 2 at 2 seconds. The third question is, what is the maximum height of the ball? The turning point is 284, so the maximum height of the ball is 184 feet. The fourth question is, the ball hits the ground when t equals what? The ground is at a height of 0, so we set h of t equal to 0 and solve. We'll use the quadratic formula. In the quadratic formula, b here is 84, a is negative 21, and c is 100. So when we run all of these numbers through the quadratic formula, we find that t is approximately 4.96 and negative 0.96. We conclude that the ball hits the ground at t equals about 4.96 seconds. We also see that our height function is equal to 0 when t is negative 0.96. But since t needs to be greater than or equal to 0 here, we don't use this solution. T needs to be greater than or equal to 0 because we're talking about time. Here's a graph of the function with that negative time component marked in a dashed line here, so you can see where that 0.96 would occur, but that's not part of our solution. Let's check our work. For initial height, we have two versions of our height function, so we'll check them both. The standard form and the turning point form. In both cases, we get 100 for our initial height, so that checks. The next question is our turning point. For 2, we're supposed to get 184 feet for 2 seconds. In both cases, we get that, so that checks. When does the ball hit the ground? It's supposed to be at 4.96. When we check both function forms, in both cases we get 0, so that checks. So here is our answer. The initial height is 100 feet, and that's marked on our graph. For 2 and 3, the maximum height is at 2 seconds and is 184 feet. And for part 4, the ball hits the ground at about t equals 4.96 seconds.